Hello everybody and welcome to another video here at Sage of the Six Maths. For those of you who don't know, my name is Bogdan. I'm a local tutor here in Strathroy, Ontario, and I just started this little YouTube channel to sort of help my students and give them access to some of the questions that maybe we might not have time to get to during our regular sessions. So without further ado, I'm going to be attempting to graph this function here using our derivatives, okay? And what we've learned so far in grade 12 calculus from derivatives. So the things that we need to look for are intercepts, our intervals of increase and decrease, and we have our intervals of concavity. Okay? Those are the things we're going to try to look for in this graph. And after we get all these clues, we're going to attempt to graph it. Okay? So, looking at our intercepts, for these we're going to have to try and have y equal to 0 and x equal to 0, and seeing what happens if we can get values or points that we can use to plot on our graph, right? So if we set y equal to 0, right, we'll have 0 is equal to x ln of x squared, okay? So now over here on the right hand side, as we've seen many times before in the past, we have a product of two things, right? So setting either one equal to 0 is going to give us 0, right? So let's start off with our ln of x squared. We know that ln of 1 is equal to 0, right? And so what that means is that our x squared, the inside part, has to be equal to 1, right? So we have x squared is equal to 1, and x is equal to plus or minus 1, right? Taking the square root of both sides here. When we take the square root here, we have to consider both the positive and the negative 1 value. So both of these values will give us ln of 1, because if we put in a negative 1 here, squared is going to be positive, so it's just going to be ln of 1, which is 0. The positive 1 is obviously going to be positive. That's going to give us 0 once again, okay? That will make this whole thing 0. So I know that we have points here. I have 1, 0, and negative 1, 0. Okay? Right away we got some clues. Over here we're going to try and set x equal to 0. Now, setting x equal to 0 will make this part 0, but if I put 0 into this part, well, if we remember what our graph of the natural log of x looks like, I'm just going to draw it over here really quickly. It looks like this, and it comes up from the bottom here, and it goes up like this, right? So if it never actually touches 0, the x value of 0 here, it never touches the y-axis, right? So if you put that in your calculator, you'll get an error because it doesn't actually exist at 0. So our function here doesn't actually exist at 0. So we've got something weird going on over there at 0, because if I plug in a negative value into this function, we already know from this point here, if I plug in negative 1 here, this is going to be 0, right, which will make this part 0. Now if I plug in negative 2, we're going to have negative 2 squared is going to be positive 4. Well, positive 4 exists over here, but that's going to be multiplied by negative 4 again, so it's going to give us a negative number. So we do have something that exists on the left side of the y-axis for our function, but it doesn't look like it exists at x. Okay, so x cannot equal 0. We have something going on there, either an asymptote or a hole or something that our function doesn't like it. Okay, but it looks like it exists everywhere else. Right, so we're gonna have to, we'll do that part at the end when we take care of our limits. We'll see what's going on here at this x cannot equal 0. Okay, intervals of increase decrease, we're going to take the derivative of this function. Okay, to take the derivative, y prime, we see once again we have a product of two functions, so we're going to have to use the product rule. Okay, taking the derivative of the first part, which is just 1, and we leave the second function alone, so it's just going to be ln of x squared, plus leaving the first part alone, taking the derivative of the second function. Well, that's just going to be 1 over x squared, and that's going to be multiplied by the derivative of the inside function, which is 2x, right? Well, here on top, this part here just becomes 2x squared. The bottom is still an x squared, right? My x squareds cancel out, and we're just left with a 2 over here. So I'm just going to rewrite it over here. My 1 disappears because 1 multiplied by anything is just going to be this thing, right? I have ln of x squared plus 2, okay? So now over here, what am I going to do? I'm actually just going to leave it like this for now. And the reason why I'm doing that is because we have to make our first derivative equal to 0, right? In order to make it equal to 0, I have to make this part equal 0, right? So if I make this equal to 0 here, I'm going to move the 2 over. So I'm going to have ln of x squared is equal to -2, okay? Now, when we do this, if we remember our rules of logarithms, we can change this form into an exponent, okay? So, because ln, or natural log here, is actually log base e, right? To the x squared here is equal to -2. So in order to rewrite this, what I can do is my base will be e for the exponential function. My exponent will be -2, and that will equal x squared. Okay? Now I have to take the square root of both sides here. Same way that I did it up here, I have to consider the positive and negative component of this square root. Okay, so on this side, I'm going to take my x and I'm going to move it over here. Okay, I'm going to have x equals, and here it's going to be the square root of 1 over e squared, right? My e is just a constant. So this can be rewritten out as the square root of 1 over the square root of e squared. Well, the square root of 1 is just 1, right? And the square root of e squared is just e. And also remembering that we need to consider the positive and negative components here on this side once we take the square root, right? Okay? So, what does that mean? That means we have flat slopes of tangent lines at positive and negative 1 over e, okay? That means we have either a max or a min. To determine whether it's a max or a min, we have to do our intervals of increase, decrease, right? Because if we have an increase, an interval of increase followed by an interval of decrease before and after these points, then we have a maximum. If we have a decrease followed by an increase, we will have a minimum. Right? So I'm going to put my 0 over here. And I'm just going to write these arbitrary hash marks here. This is going to be my positive 1 over e. This is going to be my negative 1 over e. And now I have to set up these intervals. Okay, so I like to put these, and I have 3 intervals here. This one here, this one, and this one. Okay? Well, before I have to put in something that's before negative 1 over e. So if you just throw 1 divided by e into your calculator, you'll see that you'll get a value of 0.367. Okay? So this is negative 0.367. This is positive 0.367, excuse me. And so we have to put in a value that comes before this. So I'm just going to go ahead and plug in negative 1 into my first derivative here. Okay? If I plug in negative 1 here, I'm just going to have ln of 1, which is, we know, is 0 from up here. That's going to be plus 2. That's going to be a positive value. Okay? So we have an interval of increase on this side. Plugging in 0. We have an issue here once again. Remember when we plugged in 0 over here, you can't do the natural log of 0. So 0, this derivative, also cannot equal 0. So I have to pick a different value over here, okay? I'm just going to pick, I can't pick 1 because that's too big. So I'm going to pick like 0.1, let's say, okay? So if you do that in your calculator, 0.1 squared, then you take the ln, or the natural log of that, it'll be negative 4.6 plus our 2, it's going to be negative. So here we have a negative in between negative 1 over e and positive 1 over e. Now on this side, I can just do positive 1. Okay, once again, we're going to have ln of 1, which is going to be 0, plus 2, that is going to be positive once again. So here I have increasing and then decreasing. This is a max. Whoops, that's way too many bumps. Max. At this point, I have a decreasing and then an increasing tangent lines. So this is going to be a min value. Okay, I just like to put points like, or put little notes like that to remind me what I've just found here, right? Give me more information, more clues for drawing our graph later on, okay? Of course, to find these points, we're going to have to just plug them into our original function, okay? So if we plug in negative 1 over e, let's see here. I got a value of negative 0.049. 0.049. It's going to be my max there, okay? Should be a negative. 1 second. This should be a negative number, so I don't think that's correct. Give me a minute here. Sorry. It is a positive number. I made a mistake there. I forgot to take the natural logarithm. So it's going to be 0.736, 0.736, and then here plugging in positive 1 over e. That's going to give me my minimum value. It's going to be negative 0.736. Okay, so positive and negative over here on this side. All right. Now, we have our two max and min points. Now I'm going to go ahead and take the second derivative down here. Okay, I'm going to do the second derivative in green. My second derivative over here is, let's see, I'm going to use this form here to take my second derivative, okay? So, taking the derivative of this is going to be 1 over x squared. The top is actually going to be multiplied by 2x because that's the derivative of the inside function, right? Plus 0, the derivative of a constant is 0, right? I can, what do I got here? I have 1x on top. I can cancel that out with one of the x's from the bottom. So I'm just going to be left with 2 over x. Okay? Now, here, once again, x cannot equal 0, but I do have positive and I can put positive and negative values in for this, right? So if I do my number line here, I just want to know what's going to be happening before and after 0. Before 0, it's going to be negative. A positive divided by a negative number is going to give me a negative. And then a positive divided by a positive, of course, is going to give us a positive, right? So we're starting with concave down, and then we're going to go concave up after 0. So it looks like 0 is actually going to be our inflection point over here, just judging by what we found out over here, okay? Last thing we need to do is take limits, okay? Limits as x approaches infinity, limit as x approaches negative infinity of our functions. Okay? As it approaches infinity, well, if I put in a really large number for infinity for x over here, it's going to be infinity. The natural log of infinity, well, looking at our graph of natural log, it goes up to positive infinity. So I just have positive infinity multiplied by positive infinity. That's just going to be positive infinity. Here we have negative infinity, right? So it's going to be negative multiplied by, if I put a negative infinity here, we're squaring it. So it turns into a positive. So this part's going to be positive infinity. So positive times a negative is going to be negative. We're going to have negative infinity on this side. One more thing we have to be really careful with here is going to be this x cannot equal 0 value. So I want to see what's going on. What's my behavior like as my function is approaching this? Is it going towards infinity? Or is it going to be a whole? Does it just continue? Is it the same from either side, right? Well, the limit as x approaches 0 from the right, and the limit as x approaches 0 from the left. As x approaches 0 from the right-hand side, so you want to plug in a value that's positive but really, really close to 0. So you want to put in a value like 0.01 or 0.1. You'll see that you will get a number that is really, really small. Okay, if you plug that into your calculator, so from the right-hand side, the limit is 0. From the left-hand side, the limit is 0 as well. Okay, so that tells us this is a whole. Okay, so going ahead and plotting this. we're going to use all of our clues. Cannot equal 0, right? So we have a hole right at the origin. We're plotting our points, 1 and 0. So we have, I'm going to make this my 1. I'm going to make this my -1, because I have -1 and 0 as well. I have a point here, I have a point here. Okay, and I have these points here, right? -0.36. So that's going to be -0.36 somewhere around here, and then 0.7. So if I put my 1 hash mark up here, it's going to be somewhere over here. Okay, and then I have 0.36 on this side, and I have -0.7, right? So it's going to be here and here somewhere, okay? And these are my max and my mins, okay? All right, so coming from the left side of the graph here, I'm approaching negative infinity, so I'm coming up from here. I'm going through this point. That's my max here. And I'm going down through my hole. This is my min. And I'm coming up through this point, and I'm going up towards positive infinity. And it should be a little, there you go. If you guys have graph paper at home, please draw it a little bit cleaner than that, but this is sort of the general shape of what you're going to see here. The main trick here with this question was this x squared part inside the natural logarithm. So when you plug in 0 for this, or when you make this part equal to 0, excuse me, you know that you're going to have to make this x squared equal to 1, and we have to consider both the positive and the negative side of that square root. But other than that, this is what it looks like. I hope that helps, and I hope everyone has a great rest of their day. Have a good one.